Okay, in today's lesson we're going to be looking at the motion of a particle in a straight line. Now, all of these notes, including the proofs for the equations of motion and many more examples you have been given, you will have filled them out in class and we would have went through them and explained them. However, today's lesson is just a recap of the main equations of motion and generally how you would use them. Okay, now before we begin, you've got the basic notation. S is the displacement in meters, U is initial velocity, meters per second, V final velocity, meters per second, A is acceleration, meters per second squared, and T is time in seconds. And these are the 5 equations of motion that you're going to need to learn. Make sure you know them off by heart. V equals U plus AT, S equals a half U plus V times T, V squared equals U squared plus 2AS, S equals UT plus half AT squared, S equals VT minus a half AT squared. Now we're going to look at an example. A car accelerates uniformly while travelling down a straight road at a constant rate of 1.5 meters per second squared. It passes A at a speed of 4 meters per second and takes 8 seconds to get to B. Find part A, the speed of the car at B, and part B, the distance between A and B. Okay, so let's look at the information we're given. We're given the acceleration, 1.5 meters per second squared. We're given the initial velocity, 4, and you're given the time, 8. And you want to find the velocity as it gets to B, which is the final velocity. So the first thing you should do in all of these questions is list down what information you know and what information you're trying to find. So at the beginning we've got A, U, and T, and we're trying to find V. And the second part, B, we're going to find S. Okay, so we're trying to find a formula that connects V, T, U, and A. So V equals V equals U plus AT. Okay, the final velocity is the initial velocity plus acceleration times time. So you're going to do V equals, and you're just substituting the values, U4 plus 1.5 times 8. 1.5 times 8 is going to be 12, plus 4 is 16 meters per second. Now what we're going to do is we're going to work out the distance from A to B. Now the distance from A to B is just going to be the displacement of this journey, so it's S. Now notice here, what I'm going to be doing is I'm going to be trying to find S. Now I'm going to avoid using V. The reason I'm going to avoid using V is, it may be wrong. You may have made a mistake in part A. So in this particular question, I can use the 3 bits of information they give me at the beginning and S, and use a formula just using those bits of information. So we're going to use S equals UT plus half AT squared here. So S displacement is equal to U4 times T, 8 plus a half, times 1.5 times 8 squared, which is 64. Multiply all that and you would get that the displacement is 80 meters. Okay, we're going to look at another example now. The ball is thrown upwards with speed U meters per second, and after 4 seconds it is moving downwards with a speed of 5 meters per second. Find part A, U, the initial speed or the speed of the projection, and B, the greatest height reached by the ball. Okay, the initial information we know in this question are as follows. Well, because it's just thrown, it's the only thing going to be making it accelerate will be gravity. So A is going to be minus 9.8. It's minus 9.8 because it's travelling upwards with a speed to begin with, and so it's going to be slowing down to begin with. So we're going to let A equal minus 9.8. U is the initial velocity, which is U. T is 4. And it's going to be moving downwards, which is the opposite direction to which it was beginning. So it's going to be travelling. So the V is going to be minus 5. Okay, formula connecting those is going to be simply V equals U plus AT. So minus 5 equals U plus A minus 9.8 times T, 4. So you get minus 5 equals U plus minus 9.8 times 4. You work that out, you get minus 5 equals U minus 39.2. You bring the 39.2 across the other side, and you get U equals 34.2 meters per second. Okay, So we've got the initial velocity as the velocity is projected upwards as 34.2 meters per second. Now what we're going to do is we're going to find the greatest height reached. Now for the greatest height reached, well, again, acceleration is going to be minus 9.8. It's going to be slowing down after it's projected upwards. Now at the greatest height, the speed is 0. That's just before, whenever you throw something upwards, the greatest height it reaches is, it stops and then it starts moving downwards. So the v is going to be 0. U is 34.2 and S is the displacement we're trying to find. So what we're going to use is we're going to use v squared equals u squared plus 2as. So naught squared is naught. 34.2 squared, you can work that out, and 2as, 2 times minus 9.8 and then times s. So you get naught equals 1169.64 minus 19.6 s, and then you bring it out across and you solve it, and you get the displacement, the greatest height reached by the ball